welcome to LADYADA.
Hey everybody, and welcome to a fabulous Sunday night stream. It's me, LADYADA. With me on camera control is Mr. LADYADA, and we're at my desk. This is the desk of LADYADA. This is where all the magic happens. This is where I'll be found dead one day. So we had a fun Stemma Sunday, and I designed a new Stemma board. But first, we have some website news.
Yeah, so I just wanted to give folks a heads up because we're constantly updating Adafruit.com, and unfortunately there's no such thing as the electronics press. Most of the companies that are like Electronics Journal, they're just owned by big companies, so they just do press releases for big companies.
We don't really do press releases.
Yeah, and so, we do electronic news, but it's things that we like, and there's editorial, and there's a code of ethics and all that stuff. But all the rest of these things, unless you're a giant company, you don't get coverage.
Right.
So we have to talk about things we're doing on our site, especially when they're innovative.
We have.
Yeah. So
constantly.
So here's our website, adafruit.com, and there's a couple new things. First up, most people want to know what's new.
What's new?
So we have a button.
Just click it.
It says what's new. And that's where most people go right away, so we put that front and center.
I go there constantly. Now,
if you were, back in the old days, or just even right now, when you hit products, you can see all the new products here. You get featured products and all the categories, and that's super fun. But you may also notice something else. Live. So we do...
Wait, we are live right now.
We're live right now. So let's see what happens when we click live.
Oh, no. Oh, my God.
Oh, look. It's an ad.
It's an...
Yeah, because this browser is signed out. So let's...
You can skip it.
Yeah, let's skip this ad. Hey, look.
Whoa.
It's us talking about us talking about us. Hey, look, we can go premium without the ads.
Whoa.
So anyways, so that's the things that we added. We also have, the flexible messaging area up here that's been here for a while. We have voting resources. We have our safety protocols. We're the only electronics company that I know of that publishes safety protocols. And we also have voting resources for everybody out there. So one of the other things that we do is the live thing will go to whatever scheduled video is coming up, or it'll just go to our videos page. But one of the things that we do every single Tuesday is JP's product pick.
Yeah.
And the product pick, and I'm just going to go and pick like one of the most recent things. So this is Cutie Pie. Now this isn't an original idea. We saw how giant e-com sites in China operate, and they make Amazon look silly. They broadcast from product pages, and they're like, when you're watching the show, you're actually buying the product. So we did one live from Stemma, Cutie Pie. So adafruit.com/cutie-pie, JP broadcasted live, and this show was live inside of the product page. This is, I tried to talk to some electronic, trade journalists, and they're like, well, like, we're really interested in mergers between, like, gold chip and silver chip. So here's I think this is innovation in the electronic space, because no one talks about the marketing of other maker companies do, or they'll try to talk with each other. But this is something we think is here to stay. If you do electronics, you're going to need to do something like this, where you have a live section, you have what's new, you have something like an Adafruit learning system, you have important messages like right now, vote. And so that's just some site news I wanted to show off. So back to the regularly scheduled programming. What are you doing this week on LADYADA?
Okay, so as mentioned, making a new Stemma board. So let's look at the computer. Let's go to the computer, and we'll show off the files, and we'll show off the product. So I saw this pop up on Digi-Key.com/new. I'm picking it for this week's NPI. Don't tell anybody. That's a secret. And this, the Bosch pressure sensor series, it's kind of famous, right? They started with the BMP085, then the BMP180, 183, 280, E280, 680, and then they started going to the 3 series. And the 3 series, it's so incredibly precise that, it can do altitude detection to a couple centimeters, which is pretty amazing. So it's meant for industrial use, like drones or other robotics where altitude is important. You want to know the absolute orientation, because like if you use GPS, especially if you use RTK GPS, you can get like XY precision to be very good. And then with IMUs, you can do like orientation detection, and then this gives you height detection from sea level. So it's very handy. This new sensor just came out, the BMP390, and thankfully it's the same pinout shape as the 388, which we already had in the store. And I was designing a Stemma QT board for the BMP388. Folks who are watching the Adafruit shop will notice I have been revising every sensor that we have made over the last like 10 plus years and turning it into the Stemma QT format. 1 inch by 0.7 inches, 2 or 4 mounting hole, text at the top, 2 plug and play connectors on the right. The idea is that I want all our sensors to be as similar in size as possible to make mechanical design easier, and also to have that plug and play Stemma quick compatibility, because I think that for a lot of people's projects, like we saw with the Cutie Pie, you just want to like plug in stuff. You don't even want to do any soldering. You don't want to do connecting. You just want to have wires that connect your OLEDs and your sensors and your GPIO breakouts and your ADCs. So the BMP388 was actually on my list to do, and so I did that. And because the BMP390 had just gone into Digi-Key shop, I picked up a couple and I soldered it onto a PCB. So let's just quickly look at the overhead, and I'll just show you the PCB here. So it's so small, I gotta get a little closer. Okay, so this is the BMP388, but I have the 390 soldered on. I like it when companies use the same pin shape and pin out, package shape and pin out for their sensors, especially when they upgrade them. It just makes it so I can reuse stencil and I can kind of like reuse the PCB design. So it was quite nice to see that the 390 was kind of like the same as the 388. It was just internally there's some better calibration or sensor management, but it's pretty much like identical. The whole 3 series I think is going to be. They have one API for all of them, so that's good news. And then on the computer, you can go back to the computer. I can show the output. We've got, I don't think, oh yeah, I can make this font bigger. Look at that. Get the temperature, barometric pressure, and then convert that to altitude. And, what's impressive is as I lift it up the table a little bit, you can see the altitude go up, to 50.56 meters. And then if I put it back down on the table, it goes down to 0.24. So, or 0.1. So it is, nearly centimeter level precision, especially the way I'm running it now where I'm doing oversampling. I take 16 samples and then it averages them. That's done in chip. And that oversampling, it slows down the sensor, but you'll get, we're going to have a little bit of that noise. So you'll get a more accurate reading. So that's the BMP390. So I'm going to basically just change the silk screen on this PCB and then panelize it and send it out as I've shown in other videos. So the next thing I was working on is we had the Stemma Friend, and I thought I would kind of like work on it sort of in parallel. So one of the things I did in the last week is create an I2C sniffer. So yeah, let's go back to the overhead if that's cool. Now I will zoom out. So we've got here the Metro, and the Metro is connected to the sensor, and then the other side of the sensor is actually connected to the Stemma Friend, which is the SAMD21 on here. I actually figured out a way to turn it into an I2C sniffer. So it's actually reading the GPIO lines really, really fast, kind of using the lowest level GPIO reads. And then, I never actually read the I2C specification, but it's actually not too hard. You're just looking for some pin transitions, and it tells you how the data is read. It's very specific. The clock line is low, and then if the SDA line transitions while it's low, that means it's a stop or a start, and then data just comes in 8 bits at a time. So it's not too bad. And I was able to, by using the lowest level reads, I can GPIO bit bang read I2C signals that are coming in even at 100 kilohertz, which is kind of the standard I2C. I think if I wanted 400 kilohertz or megahertz, I would have to go to a SAMD51. But SAMD21 actually works. So let's look at that on the computer screen. So this is the data coming in. This is the Metro, again, reading the BMP390, and then I'm BitBang reading it. So I'll just turn off scrolling. So the S here stands for start. That's the start bit detect. And then there's this EE. And if you know the BMP series, you're like, well, why is the first byte EE, like on all of them? And that's because, you remember I2C addresses are 7 bits, and then they're shifted over when you do a data read. So if you take EE and you divide it by 2, you get 77, which is the standard I2C address that we use for BMP sensors. So this is start read from address 77. This is write to address 77. 1B, so that means, write that data value. That usually means you're going to read that register value, 1B. And then you see another start, so repeated start. And then EF, which is, again, 77 shifted over with a 1 bit, which means I'm now going to read that data, and I'm going to read 3. And then this is a NAC, which means there's no more data to be read, and then P for stop. So this is just one I2C transaction. And then, you can see here a longer transaction, but basically starts, data, repeated starts, more data, NAC, and stop. And then what I can do next is turn that into like a more understandable I2C transaction. So good stuff happening here. The data seems pretty good. It seems complete. So now I just have to do the formatting to get it into like a more like readable, because most people don't read the 7-bit address that way. They want to see like read address, write address. I don't want to like have to shift bits around, and usually people don't care about the NAC bit at the end or the stop. They just want to see like here's one transaction. So I'll keep working on that. It's a little slow going to get the sniffer code going. There's like a ring buffer that I had to do, and I used 2 IRQs, one on each SCL and SDA pin for when they do a pin change, and then you have to kind of like do this port level read. And when you use port level reads, that's when you can get like very fast data reads. If you use digital read or digital write, it's much too slow because it has to go through like multiple layers of like translation. So in this case, I'm actually just like reading the raw data. Sort of like, when people had AVRs, they would use pin B and port B and DDRB, like the raw level register. That was kind of the only way to do it. It's like that, but thankfully there's a little helper. This register is very nicely described. So this is how you read the data raw, and then I put the data into a 8K ring buffer, and that's plenty long enough for very long transactions. So more to come with that. Okay, and then next up, I was playing with
you want to do a question?
Oh yeah, ask more questions.
All right, I answered. AdaBox are shipping this week, next week. So
next week.
Go to adabox.com, get yours now.
Yeah.
And if you sign up, guess what? You get one. But we only have a few slots.
We don't have that many left.
Yep.
We actually have maybe, I think, like a dozen or so.
Okay, next up.
Okay.
Any news regarding the NAU 7802 Stemma board that was in the works a few months ago? It's the 24-bit ADC for low cells.
Yeah, I gotta finish it one day.
Yeah, so there you go.
I was doing it just like in the middle of March, and then kind of everything in the middle of March sort of got thrown into a plate.
Oh yeah, why?
I don't know.
Kind of boring summer.
I had a really boring March.
Nothing's been going on really.
Yeah, and it's like it doesn't make sense. It's like I've done newer things in, but it's just been like I have to push the items off the stack.
Yeah.
All right, so a lot of people have picked up Matrix Bonnet, which is sweet. And one thing that, sorry, not Matrix, Matrix Portal. I always get that mixed up. We have Matrix Bonnet and Matrix Portal. So we designed the Matrix Portal to plug into the back of LED matrices. But one thing that a few people have asked, and I will want to write up, is whether you can connect it to multiple matrices. And the answer is yes, you can, by chaining the matrices together. So for example, I'll see if I can just light this up. Can you just go to like Play Me? I think because it's kind of small. So, for example, this is the 32 by 64 matrix project, except I just changed it to 30 to 96 because it's now 2 matrices in a row. And you'll see even that these aren't the right pitch because this is kind of what I had kicking around the house. The data can go as many panels as you want. You just chain them together using I2C cable. So the power cable that you get when you get these matrices, it actually has usually 2 connectors, so that makes it really easy to connect 2 devices like instantly. Yeah, so the cable like looks like this, and it has 2 of these little like Molex chunky ends, so you can just plug it in. And then you use one of these I2C cables, and this isn't for power, this is just for data. So the power comes through these thick cables, and the data goes through these thin cables. And these I2C cables, you can get them in any length. So if you even want to have the matrices like separated, they don't have to be right next to each other, like most people do.
You make a cube?
You can make a cube, for example, which might be a project that I want to work on. Because we did a cube a long time ago, but it was like using HDMI only, and I think now we could do it with the matrix portal. Could definitely drive a cube. I could maybe do like 3D pixel dust. Which brings us to the great search, where we'll show how to get custom I2C cables from Digi-Key.
Couple things before you go into the great search.
Yeah.
How much are those panels?
Well, each panel is a little bit different price.
Yeah,
but
go to this product page and check it out.
Let's go to, hold on, let me go to like 3264 LED. So it depends, but they're like, $40 for a 64 by 32. The 64 by 64s are more expensive because it has twice as many pixels, so like 55. So it's going to be basically between like $40 and $60, depending on the size, the pitch, the number of pixels. The 16 by 32s are very inexpensive, but you get not a lot of pixels. See if I can find it. Hold on. It's either 16 by 32. So these are $25. So that's as cheap as it's going to get, but it's only 16 by 32, and most people want like a ton of pixels. 16 by 32 is not much, but it is, considering how many LEDs you get, the price is really good.
Okay.
Okay.
And it is time for the great search.
That's right.
Where in the world is that part I need? The great search with Digi-Key.
Every single week we do the great search. The Digi-Key LADYADA shows you how to find all the things you're looking for on the Digi-Key site. What is the great search this week, LADYADA?
Okay, so this week we're going to show how to chain together these RGB LED matrices. If you've picked up a matrix portal from Adafruit or Digi-Key, you want to connect multiple matrices together, especially if you need a custom cable length. I2C cables are really, really popular. They're incredibly inexpensive. They're kind of a standard. They use 0.1 inch spacing. They're fairly easy to put together, especially if you have factory. They don't have like weird you have to get contacts in. You basically just like crimp them down all at once. That's why it makes them very cheap and common, is because they're very simple to manufacture. And you can get these like crimper things that allow you to create your own I2C cables. And I've done this, and Phil, you remember we had a little press that we made I2C cables with, and it kind of sucks. So what I do recommend is, just get the cables pre-made from Digi-Key. They'll do it for you, especially if you only need a couple. You don't want to pick up, these are, not inexpensive tools. And if you don't have to make them yourself, just get them at Digi-Key. They're only a couple bucks, and you can get them in like any size, length, and configuration you want. So the cables that we will be getting, do you mind if we go to the overhead real fast? These I2C cables that go between RGB matrices. So you'll know the common I2C matrix, the common I2C cable, by the fact that they tend to be 2 rows. Very common. It's rare to see 1 row. There'll be this little nub here sometimes, and that matches with a cutout on, you can even see on the silk screen, there's a little notch. That's the polarizing key. There's often a red marking on the connector. You'll also know that these are very common, they're used with Raspberry Pi. So like, this is a Raspberry Pi with an IDC connector as well. Also the same dual row 40 pin. This one is less, so this one is dual row, 8 pins, right? So you count them, 8 pins 2 times, 16 pin total, has a polarizing key. So that's something we have to watch for. We want to make sure that we get that. And then, we can get these in almost every length and size and color, but we won't care about the color too much this time. So let's go to the computer. Okay, so in case you're wondering all about IDC connectors, like what does IDC stand for? And I was like, I don't remember. Insulation Displacement Connector. And again, they look like this. They have these little notches in the connector that when you connect them, they crimp, they go into the ribbon cable and kind of nick it, and that's what makes the contacts. And you can get them with like DB connectors on the end. We want in this case. Another thing that's really cool about them is you can have them like in the center. If you people remember putting together computers, and you had like SCSI drives or what's it called, IDE drives, and you remember or floppy, you'd have like 2 of these connectors on one cable. Nowadays people use SATA, so this is not as common, but that's, again, incredibly popular cable. So let's go to Digi-Key. And luckily, searching for IDC cables is really easy. You start with IDC cables, right? Classic. And then you can get parts to make your own if you so wish. Like if you just want that crimpy part. But again, you need to like use a vise to make it squish evenly. That said, they come in like panel mount style, and they come in like free hanging style, and like they come with like little hooky things on the side, and that grabs the cable and keeps it in place, which is amazing. There's a lot of innovation in IDC cables. Gold plate, tin plate. Anyway, so if you want to make your own cables, go to town. There's also D-sub versions, right? But what we're going to look at is the assemblies. Now, assemblies are interesting. You can get cable assemblies from Digi-Key. Thing to watch for is they're not in stock. They'll take a day sometimes because somebody actually has to make the cable for you. And especially if you're making a bunch of cables, they may not be like socked cables. That said, we should always look for active cables. And okay, so the first thing we're going to do is we're going to look at number of positions. Again, 2 by 8 means 16 total things that stick in. So let's apply that. Okay, next up, how many rows? Again, number of rows is like 2. If it's not 2, something's weird. IDC cables are almost always 2. Next up, there's the pitch of the cable and the pitch of the connector. Now, there are 2mm pitch or 1.27 pitch connectors. People will actually see 1.27 pitch connectors on SWD cables. If you've ever had to debug a board, I don't know if I have. Yeah, hold on. Can you go to the overhead real fast and I'll show this. If you ever have something with like a SWD or JTAG debug, you might see these like, it's IDC, right? It's got that same notch and it's got the same dual row like connector, but this is 0.05 inch, not 0.1 inch. So it's like ultra fine. You'll know when you see these because they're like, wow, it looks like an IDC, but like shrunken down. That's when you're using 1.27 millimeter, but it's not common for like when you're usually dealing with these kind of cables because these are a little bit more expensive. Okay, so back to the computer. So for the pitch of the connector, we want 2.54, and then the pitch of the cable is going to be half because the cable connectors are 2 per lane and they alternate. Anyways, it's just believe me, it's going to be 0.1 inch, and then it actually won't even show up if you select 0.1 inch spacing because they have to be 0.05. And then there's a couple there's like all the options for like strain relief and stuff. But let's look at all the connector ends. So you can get them with like raw cable on the end. So there's only like one plug-E part. You can get them with different connector orientations. So like this is the the plug. There's like the socket version and the plug version. See how this one has like the holes, and then this is So this is the socket, and this is the plug. And so you can like make extension cables. You can have ones that plug into IDCs. Like again, this is a innovative place. So you can get like ones with flanges for like mounting, all sorts of stuff. We want the standard plug to plug. Like we want this, which is, sorry, that's a socket. Gotta get that right. This is a socket. Get the socket connected to a socket. So let's do socket to socket. I think this is what we want. Okay, yeah, that looks right. You have 2 sockets on either side. And then we get to choose, I mean, there's kind of like a whole bunch of stuff. There's like basically length. So let's just say we want like about 3 feet. So let's select all of these options. Like 3 to 4 feet. I don't know, I really want a long cable for some reason. Okay. And then, do you want the polarizing key and strain relief? The strain relief is the folded over part. So if you go to the overhead, I'll show you what I mean. So this part here, this is the strain relief. It's actually not necessary. You can do without, but it's just like you'll, like if you see on this cable, there's no strain relief. The cable just comes out and it's connected and it's crimped on and it's strong, but it doesn't have that extra thing at the top that doubles over the cable. Whether you want it or not, it doesn't matter, but you might have situations where you want a little bit more protection, especially if somebody's yanking it back and forth a lot. Okay, let's go back to the computer and we'll wrap it up. Okay. So we do want the polarizing key, and I don't care about strain relief, so let's get that. And then finally, I'm going to do my favorite thing, which I sort by price. And this is what came up. So this is socket to socket, 16 pin, 2 row, unshielded, has a polarizing key, is 3 feet long, uses the gray ribbon. I guess you can get like rainbow. And there's tin and gold plate. It's up to you whether you want tin or gold. I mean, the cost difference is 1 cent. So honestly, you probably want to go for gold if you're doing it. And then this is the rendering of what you're going to get. Note that's just a rendering. It's not the actual thing. And then, there's, if you want something slightly different, they give you the ordering code. And then when you order this is a value-added item. What does that mean? It means that they have to assemble it, when they get the order. So you can order as many as you want, but it's not going to like ship immediately. It's going to take, a day, or depending on how many, a couple days. And then, if you order a bunch, there are discounts. So, if you get to like 100 or 200, you're basically going to drop down to like, $1.50 per cable. And this is a pretty long cable, like 3 feet, so not a minimal amount of size. So if you want shorter cables, they definitely can be inexpensive, so you can see why people really like IDC cables. So next time you see an IDC cable and you're just like, do I have to crimp that? The answer is no. Digi-Key crimp it.
Does gold last longer?
The gold will be less likely to oxidize. So it does last longer, and it will, survive in a humid environment better.
Yeah.
But both are ROHS. In case you're wondering about that. All right, and that's the Great Search.
All right, that's the Great Search. We do the Great Search every single week. Thank you so much, Digi-Key, and thank you, LADYADA, for showing everyone on how to find stuff on Digi-Key.com. It is an art, it is a science, it is something LADYADA does really good, and she shares that with you every single week.
That's right.
That is.
I'm a professional engineer.
This week.
Where in the world is that part I need? The Great Search with Digi-Key.
All right,
Okay.
so we're wrapping it up.
That's that.
Just a little bit of a reminder, if you go to Adafruit.com and you click the AdaBox button, let's just pretend we're doing that. Here I am at Adafruit.com. I bookmark it. I check it all the time.
Oh, click.
I go to Adabox.com, and you can still get an Adabox right now.
Yes.
This will go away. Eventually it'll say sign up, wait for next time.
That's right.
So Adabox.com, or you can go to Adafruit.com and just click the link. And again, just a reminder, some updates on our site. We have What's New button.
What's new? What's new?
That gets you directly new products. We are on a new product roll. A lot of people buy them as soon as they're in, so this is a good thing.
Yeah, we're going to be putting more e-inks in the
bookmark.
store, and then we
Yeah.
have the voice bonnet coming in next week, and then we have a whole bunch of little things, like a fingerprint sensor maybe,
Yeah.
and
Learn system.
other stuff you saw a few months ago.
We have 2,000. I'm going to take a guess.
2,000.
2,317. Yeah.
Okay, so probably
I
it's
thought
a-
it was 2315. It's 2317. And also a reminder, if you want to hang out and see a live show, we have just about a live show every day. When you click live, it'll take you there.
So we might get to like 2,500 by like March or so.
25 what?
100 guides. We're at 2,300 right now.
Yeah. Yeah, we'll have a...
We'll get to 5,000 products. I
Yeah.
wonder which product will be product number 5,000.
Yeah, we'll see. All right.
All right, thanks everybody.
So that's our show for tonight. Thank you for being part of Desk of LADYADA. We'll see everybody during the week. Tuesday is JP's product pick. Wednesday, show and tell. And Ask an Engineer. And 3D Hangouts. Thursday, JP's workshop. And Friday, a deep dive in CircuitPython with Scott. See you all next week.
Thanks everybody.
Bye-bye.